We have it available, which will be on a blog that we'll let you guys know about at the end. So again, welcome everybody. We're going to go ahead and get started. Okay, so today, here are the presenters. We're going to go ahead and have them introduce themselves real quick. Go ahead.
I'm Cassie Carley.
Go ahead, Cassie.
Sorry. I'm Cassie Carley, the Solutions Product Manager for LaserTech. And today we also have with us Johnny Thompson. Go ahead, Johnny.
Yeah, so my company is Landmark Spatial Solutions, and we, for about 17 years, have been providing technology-based solutions, mainly to folks that are working in forestry, but also stockpile measuring, and that's what we're going to talk about today. We work mainly in the southeastern U.S., but also work in some other areas as well. So thank you for joining us today.
Great. My name is Paul Atkins. Actually, I'm with Laser Technology. I'm your moderator today. Just tell you a little bit about Laser Technology. We actually got our start doing a really cool project for NASA in the early 90s. It was a device that actually measured both speed and distance for space docking missions. So we're pretty proud of that. We also then got into the recreational range-finding business, and we partnered up with Bushnell Optics, again, in the early 90s. And those are rangefinders, of course, for golf and hunting as well. And then the photo you're seeing over to the right is the actual first integration of using GPS technology and range finders for offsets, which of course we'll explain in a little bit. And that logo there just establishes we just celebrated our 30th year just last year. So again, thank you for joining us.
So Landmark Spatial Solutions has been around about 17 years there, and we focus today, we're going to focus on the MapSmart for Android, but we do a lot of other things as well. And our bread and butter for many years has been GPS, GIS solutions and mapping applications, obviously the forest measurement tools, including the lasers here we're talking about today, forest inventory applications like T-Cruise, the stockpile measuring is something that we've done for quite a number of years. Load ticketing for kind of our logging clients out there, and lastly, we've been working with some drone applications, and we'll talk about that a little bit at the end.
Okay, thanks, Johnny. Okay, so here's just a quick agenda of what we're going to cover today. Of course, MapSmart on Android software, what hardware it works with, how it works, the different things you can do. Johnny's going to go through an actual stockpile project that he measured, and it just points out how easy it is to use the program, whether you're using it for general mapping or for stockpile. We have some best practice reminders, and then of course at the end we will take questions. Also throughout, Paul will be taking questions through the chat, so if you have any, go ahead and enter them in the chat, and then Paul will interrupt us and go ahead and get those questions answered at the time you ask. So please feel free to go ahead and do that. So just quickly about MapSmart itself, over 10 years ago, MapSmart software was released on Windows Mobile. And of course, all of our software here at LaserTech is built to expand the capability of our lasers. So then when our Impulse laser evolved into the TruePulse, we then wanted to update the MapSmart general mapping software that went along with the laser. So in April, we released MapSmart for Android. And what MapSmart does is it takes field measurements and makes them into maps. So each field measurement is a point in 3D space that can be related to other points in 3D space. And it works on any Android device running 4.1 or newer. So the measurements come into MapSmart from any of the listed equipment combos shown on this slide. Basically, any of our Bluetooth model lasers will work with or without a true angle. So your work environment, budget, accuracy needs, things like that, determine which system is better for you. And our sales managers and dealers across the country, across the world, are equipped with the knowledge to help you figure out which system is right for you. Or maybe you already have a TruePulse. Here you can see if your TruePulse will work with MapSmart right now. And another good thing about MapSmart in the bring your own device sort of environment, you can use any Android device with it. You can decide to purchase a ruggedized one because your environment requires it, or you can use what you already have. And with MapSmart on Android, unlike our old Windows Mobile version, you can use an external GPS device to increase the accuracy and actually include GPS, period. You can either get it from the Android location services if your GPS device dumps data there, or you can directly connect to the GPS device through MapSmart and get the data directly from the GPS.
We've tested several of those GPS receivers, the Geode and particularly in the PG200 in the lower left corner there, and they work very, very well with the program.
Thanks, Johnny. Thanks for letting us know. Also, I tested the Bad Elf and the Arrow here, and those work as well. It's really exciting, actually, to be able to include GPS with MapSmart when we had in the past. So on this slide, this is a graphical representation of some of the things you can measure. You can do planning, layouts for homes, yards, asset management projects, pretty much anything that needs measured or mapped, you can do with MapSmart. So this brings me to a little bit more detail about using MapSmart with GPS. At its core, MapSmart is designed for laser-based mapping. So that's measuring what you can see and using a bearing from the laser or an electronic zero determined by you to place a point in 3D space. So now the Android version includes the GPS integration. Now you can still just use your origin XYZ coordinates, or if you choose to use GPS, again, you can get that from the Android location services or directly from the GPS device. So
this is a very helpful addition to the program there, because if you're trying to take this data at the end of your project and bring it into some other program like a GIS, having the coordinates already tied to the actual points makes it very, very simple to just take that data and integrate it right into, say, something like ArcGIS. And kind of toward the end of the program here, we're going to actually demonstrate or talk about building some 3D models and things like that. And again, what makes that possible is this tying the laser points back to a known location at the very beginning. So it's very helpful.
Right, right. And so if you use GPS to set the origin in MapSmart, all the measurements in the survey have a mathematically calculated GPS offset coordinate associated with it. So although, you know, MapSmart is new with this feature, there are multiple data collection programs out there that already have the ability to do a laser offset built in from a true pulse. So,
hey, Cassie, if I could quickly interrupt, I do have a question that just came through I'd like to address. Can you connect MapSmart to an enterprise geodatabase? And if it is, can it be easily configured to automatically upload the TEH enterprise database? Oh, I think there was just a misspelling. So automatically upload to the enterprise geodatabase?
I think Johnny might know the answer to this.
Yeah, Cassie. So the way the program's configured right now, you're going to be able to export what are called GPX data out of the program. It's not going to be an automatic cloud synchronization with the enterprise geodatabase. You can very easily take in Toolbox and ArcMap there, you can take the GPX file and then convert it to a point feature in a geodatabase. And that tool is easy to use. That's how I use it routinely to get the MapSmart data over in there, but it's not going to do an automatic cloud synchronization like you might find with some of the other tools out there. I hope that helps.
Thank you, Johnny.
Question there.
Yes, yes. Okay, so all of these other developers that have written in laser offset capability with the True Pulse have done it for these three main reasons, which is, again, why we also have added it into MapSmart. So if you can't physically occupy a position because there's something in your way, whether it's a Rottweiler or a canyon or, some geographical anomaly, you can have the position that you're standing in, shoot in the position you want to know, and then have that automatically calculated without having to occupy that point. It's also faster for some workflows to stand in one position and shoot in all the others, depending on how big of an area you need to cover. And then also, if you can only get a good position in a certain spot, but you need to map in other things that are near to that spot, you get your good position where you're standing with MapSmart and then shoot in and mathematically calculate all the rest based on the good position that you were able to get. Just in case we have attendees unfamiliar with what an offset is, it's the ability to use range, inclination, and bearing from a laser to obtain the coordinate from a remote position without having to stand there. Like I said, something's in your way, you can't physically occupy the position, you can use the data from the laser, shooting to the target that you're aiming for, and retrieve the coordinate without having to go to that spot. Additionally, some things in MapSmart on Android that were not previously available was the ability to have more than one note. So before you could have notes with a point to, that could be a unique note, like a tree number or a pole number or something like that. Now you can also build your own categories and subcategories right inside MapSmart. So you could build a category called status and a subcategory called good, fair, poor, needs maintenance, whatever. You can also add a height attribute or a missing line attribute to a point. So if you're collecting, measurements to trees or positions for trees, you can include the heights of the trees. If you're doing it for utility purposes, you can add a missing line to say this tree that's this height is this far from some sort of danger or infrastructure power line sort of thing. So the missing line is a measurement you can add to that point if you need to highlight something that you need to come back and work on. You can also include photos with map points, so you can take one or more photos with your Android device and associate it with a certain point, and they're named by the file name and the point number, so you can join them together. Let's say if you're doing a CAD diagram with this data later. Also, if you're using a TruePoint 300 to take measurements, that laser of LaserTex includes a built-in camera, so you can have the photo from the TruePoint 300 come into the data as well. And then you can review and delete the photos very easily, just pulling up the point detail in MapSmart. And then, as always, MapSmart provides multiple calculations. These can help you make decisions. So right in the field, you can know if something's out of compliance, something's too tall, something's too short, and bring in people to fix that problem. And you can also help verify that you took all your measurements correctly using the different calculations in MapSmart, including volume, which Johnny is going to go over in more detail in actual project workflow, which is pretty interesting. Our report formats from MapSmart are listed here. You can just get a stockpile report directly out of MapSmart, or you can take the data and put it into a program that you want to do something further with. So for post-processing, you can use any CAD program. You can use most GIS visualization programs if you want to take the data a step further.
Cassie, I did have another question that came through regarding the photos. Are the photos from the, you're saying TrueSmart, but I believe you meant MapSmart camera geo-referenced? So are the photos from the MapSmart camera geo-reference? I'm imagining that would be like from the tablet.
Right, yes, they are from the tablet, yes, yes. Okay,
thank you.
Okay, I'm going to go to the next. Okay, so from here, Johnny's going to take it, explain how MapSmart is different for stockpile measurements, and tell us all about some of the things that he thinks are most important. Okay, go ahead.
Thanks, Cassie. So the screenshots there on the left show kind of the older original MapSmart program, and it's got some good tools on there, but they're not really organized 100%. You're kind of wondering what's going on. And so what we try to do in this newer Android version was to kind of really clean things up, make it easier to find the tools that you're looking for, and just kind of declutter the screen. So the first thing, we have a little bit larger display area there. The next kind of advantage there is your file name and your mapping method is displayed right there in front of you. We've got some icons around the edge. This one right here is a laser communication and battery indicator. And so right there it shows you if you're connected or not connected with your laser and Bluetooth, and also what your battery is on your laser, because sometimes it's a little bit hard to determine that. So that's very helpful. Easily get to your report management buttons, as well as your calculation tool is on the right side there, and also your camera. And so you've got you can easily get to your camera application to be able to take a picture of the actual control point or location that you're trying to map right there. Probably the biggest enhancement to me as a user as well is to have the different feature types very laid out, just very clearly right in front of you. And those would be the base shots, projected base, which would be where you've got either a pile that's right up against a wall, either in a bin or a big metal wall out on a chipyard, or you got two piles, say aggregate-wise, two piles that are right kind of on top of each other, and they're different size material. You could use a projected base to actually shoot a pile shot, and when you do that, it automatically projects a base shot directly underneath that. And so it's a really great feature about the program. You can map things that you can't even see. The next one is a pile shot there, and then the move or traverse button, and lastly a checkpoint. So those 5 feature types are really helpful, and again, just kind of laid out so everybody to be able to see them very easily. Lower right-hand corner, there's some zoom options. Sometimes you want to zoom in and kind of differentiate your control point versus something else. And lastly, on the bottom left corner is a remote fire button. And if you're shooting a long baseline or along back to your next control point, and maybe you don't want to move the laser with your finger at all by pushing the fire button, you can select the remote fire button and it will fire the laser for you. So very nice layout, very crisp and fresh, and just easy to get around. That's one of the things we like most about it.
Hey, Johnny, before we jump to the next slide, I had another question that kind of came through. It was regarding the reports. Which of those report formats can go right into my ESRI desktop GIS environment?
So the GPX file is going to be a georeferenced position of each laser point. And so you would take that GPX file and you just copy that to your desktop, or if you're using depends on what your device is there, you can just sync it or email it to yourself. And then in ESRI, you're going to open up Toolbox and go into your tools, and it's a GPX to feature tool, and that's the one that you're going to use. So as long as you've got a geodatabase, point geodatabase there, and geodatabase, you can put a point feature in there, and you can just simply use the convert tool and convert that straight into it. So the GPX is what you would use. I use that all the time, and it's a very easy workflow. So great question.
Great, thanks, Johnny. Yep.
One of the next features that we put into the program, and I actually requested this one myself because I use it all the time, is a checkpoint routine. And so if I'm standing at point number 69 there on the screen, and I'm going to actually start shooting my next control point down there to the south, and so I do that, and I establish that control point, and then I pick up my tripod, and I move down there to that new location. The first thing that I'm going to do before I start shooting my base and my pile shots is I'm going to shoot a checkpoint back to that previous control point. And when I do that, it's going to give me the ability to see how accurate, how close are those 2 points. And if they're very close, then what it should tell me is that my new control point to the south there, that blue box, is free of any kind of metallic interference or any kind of something that could cause my data to not be good. So if I hit next, and I shoot back to that previous control point, number 69, the next screen there is actually going to show me that I'm about a little bit less than a foot. The distance there is 0.94. So I'm less than a foot difference between that checkpoint and the previous control point. That's great. If we're within a foot on a big long baseline like that, we're doing great with this kind of equipment. And so I could then, with great confidence, know that my next base shots and pile shots would be right on. Another enhancement that we made in the program here was the ability to actually see things in 3D. So here's an actual project, and if I go in there and I start looking at the reports and I calculate my volumes, I can see things two-dimensionally right there. And then if I turn on the 3D button down at the very bottom, then I can use the X, Y, and Z tools to actually rotate my pile around and really just kind of verify that, yeah, that does look true. It does look accurate based on what I'm thinking before I even leave and go somewhere else. So it's very handy to have those.
Right, and really quickly, I just want to mention that in addition to doing a stockpile measurement like this, you can also use MapSmart to measure a void or a hole. So if you need to know how much material needs to fill in a hole or an erosion area or a discharge pit, you can use the same workflow that Johnny is about to describe to measure what would be like an inverted stockpile.
So what we thought we would do next is to take kind of an actual project and just say, here, if I was going to go do this, how would I do it? And so there's a couple of things you want to do before you actually start measuring. The first of which is pick your control points. Walk around a pile. I usually take anywhere from 5 to 7 cones with me when I go on site somewhere, and I'm going to start laying those cones out, and keep in mind distance from metallic things. We'll talk about that on the next slide, and also the fewer the cones, the better, in a sense. The fewer positions you have to occupy, the better. So you're trying to play that game where you don't want to have to shoot a control point every few feet. You want to spread those out as much as you can, but you're trying to turn and go around corners, but you're basically going to encircle the whole thing that you're measuring on a stockpile scenario. So the next thing that you want to consider as you're laying those cones out is going to be your metallic interferences. And those can be on a chip piling, and that's the world that I work in mostly because we're really centered on forestry applications in my business. But we do work with some aggregate companies as well because it's a very similar workflow. But you've got reclaimers, you've got stackers. Anywhere you got concrete, you got to be thinking about rebar. And so in a lot of scenarios, you may have to avoid metallic interferences. A lot of places that I go, you don't have to. We probably sell more of the 360 based systems than we do the angle encoder systems. But I think the next slide is going to kind of illustrate the two different types of solutions that are out there. On the left hand side, you've got a compass based. We call them the 360 systems. They're simpler, they're lighter, they're cheaper. I much prefer to use those if I can. But again, on the right side is the angle encoder system with the 200X laser, which is the old Impulse, if you've used these products in the past. And it can work anywhere. It doesn't matter. You can be right up next to a wall on concrete. You could work right next to a truck, and it would make no difference at all. The metallic would not interfere because we're not using a compass. We're using an angle encoder to turn our angles there. So part of a project workflow is to see what's out there, lay your cones out, and then pick the correct solution based on what you're faced with. The next slide, just kind of a quick reminder for those of you that do this, but you can actually plug in your magnetic declination depending on where you're working, and also do a horizontal angle calibration there. And it's very simple to do those. I do them when I'm moving from location to location. The clients that are using these can set these up one time and generally not have to worry about them unless they're changing locations there. So to kind of start an actual project then, we would open up the program. We would select a new survey, and once we go to new survey, we're gonna type in a name there. Excuse me. We're going to select our device, our method. In this case, we're saying volume with azimuth. Put in an instrument height, maybe a target height, and click next. And the next screen there is where you can actually select your origin. You can go ahead and bring in your lat long so that all of your points are georeferenced in a sense. The next thing there is you're ready to start measuring. And so again, just kind of a ABCD. It's just real simple. The workflow here, almost a wizard you could call it, in the software is really easy to step through. And so The next screen is going to show kind of an actual measurement scenario. So this is a real project I did a few months ago, and basically, some of y'all have probably done this, and some of you maybe have not done this, but we thought it'd be interesting just to kind of run through how an actual project would run. And so I'm going to shoot my base shots first, and to do that, I'm going to select my base tool up there, and then I'm going to begin taking the laser. I'm going to start shooting the base shots around this pile. And in this case, I'm shooting usable base shots. And so it's, again, the mill manager generally is going to be the one that's going to kind of tell you where to do that. Once I've shot as many of those as I need to in that tripod location, I'm going to choose my pile icon up there on the right, and then I'm going to start shooting my pile shots. And so I'll shoot in a row of those things right there in front of me. Maybe I'll shoot some to my left over there. Maybe I'll shoot some to my right. And in reality, we would shoot a lot more points, probably 300 on this whole configuration here. Not at this one location, but in total on the whole pile. So, but this will hopefully give, if you haven't done something like this, it gives you a good idea of what we're trying to work with. The next procedure here, the next part of this protocol would be to move to the next location. So to do that, we choose the traverse button. We take the laser and we actually shoot the next cone to the right there. We would then pick up our tripod, move over to that cone, re-level the tripod, and what I always do in my scenario, especially with a 360 laser, is I will shoot my checkpoint, and I'll shoot back to my previous cone, and again verify that that my new control point is not being interfered with from any kind of metallic interference. Sometimes you can see them, and sometimes you can't. If it's a buried pipe or a grate or something underground, you may or may not know if you're in a good spot unless you do the control point, the checkpoint routine there. So we've got all that data, and the scenario from here would be to continue shooting our base shots, our pile shots, move to the next cone. Base shots, pile shots, move to the next cone, shoot a checkpoint. And so here's what we actually did on this real project here, and we wound up with again a couple hundred shots there to map out that. It doesn't take very long. You can move very quickly around a pile. And the next thing we're going to do is some calculations, and there's two main ones. One is kind of what we call a traverse, and that's just from cone to cone to cone to cone. My last shot on my cone of origin, how does it compare to where that cone started? And so you can get some very good closed traverse numbers there to give you an idea of how good you turn your angles, kind of like a surveyor would do. The next thing, the main thing we're concerned about here is calculating volume. So we would click on the volume button there on the screen, and that would bring up this next screen here where it's going to automatically choose our base notes. It's going to choose all of our pile notes, projected base if we had those. We're going to choose our material type, which in this case was pine chips. And you can put in your own materials, obviously, and what the material density is. And so we're going to calculate this pile, and when we do that, it's going to find all the base shots and set a good base elevation. It's then going to triangulate all of the shots above that, as it's shown right here. Kind of looks like a mess, honestly, but when you uncheck triangles and go to contours, it actually looks a lot like your pile is. Should be exactly like your pile is. So you see your elevation lines on the left there for that ridge type pile, and on the right-hand side we had more of a flat type pile, and so it looks very reasonable. It displays our volume, it displays our weight, and we could actually click on the Save button there and actually email that to ourselves if we wanted to. And lastly, we could also look at our 3D view there as well to make sure that it was reasonable. So those are all, again, kind of a workflow of laying out a project, collecting point, base and pile points there, and then calculating your volume. That's for a lot of people, that's as far as it goes. Certainly there's different reports. We talked about going to ArcGIS, and so the next slide is going to show you, if you do take your GPX data of those laser positions and go into ArcMap, if you've got 3D Analyst in ArcMap, then you can go in and actually calculate here using your X and Y and then also your Z elevations, a two-dimensional model, and then also with ArcScene, you can go in here and do three-dimensional models. And so again, if you're working for a company, a lot of times the accounting folks out there love to see pictures. They don't necessarily understand all that you're doing out there, but they love to see a picture of it and a photograph of it. and be able to compare that back to your volume report. So those are tools that are not difficult. Kind of the next question that I think a lot of people would ask would be, what about drones? And certainly there are some really good stockpile, drone-based stockpile solutions out there. Most of those are fairly expensive, and they're going to be pretty involved to use. You're going to have some certification from FAA, and you're going to have a lot of software and a pretty stout computer to be able to crunch those numbers. So what about drones? Part of laser technologies, the beauty of their solutions for many, many years has been to take lasers and bring them to the masses, and I'm one of those masses, so I can say that. How can we take and enable, say, a mill location like this to use technology to do their own measurements? And so we've been very successful, and we've got dozens of mills down here in the South that are using this MapSmart solution to calculate volumes. Drones, I see right now, is just kind of an augmentation to that. It's another tool in a toolbox. The aggregate world seems to have great success with them because you've got piles that are on level, flat bases. The chip world is a little bit different. And so the chip world, sometimes you have piles with nice clean bases. And a lot of times, though, you've got piles that have got usable bases that are 3 feet in the air, 5 feet in the air. Maybe some of these stacker reclaimer situations, you may have them 15, 20 feet in the air. So it's a little more difficult if you can't get a good base set to use a drone to calculate your actual volume there. So it's a great tool. I see it as something that we're starting to use those in our measurements to do some comparative work with, and I see a place for them, but I don't know that it's going to be a replacement. The laser solutions are very cost effective, very easy to use and fast, and I think we're going to see both of those technologies being kind of work simultaneously as time goes on. A couple of just kind of reminders. We've talked about most of these, but I wanted to just put them all in one list. And I've been doing this for about 10 or 12 years, and so I've kind of put together what I work through mentally when I go do a job. But cone setup is absolutely critical. Minimize metal. Make sure you're aware of as much metal things as you can, and pick the right tool for the job. And in some cases, it may be the 360 is the preferred route. In some cases, the angle encoder may be the better option. It's all about the base. Make sure there's no obstructions when you're shooting your base. Sometimes if you're shooting log decks or even some chip piles, you may have some vegetation. You want to make sure you clear that out, get good base shots. Use the projected base shots when necessary. Remember, there's a science and an art. The science is the laser and the technology, and it's very, very strong. You can rely on that. The art is as a operator there, you've got to look at that pile and you've got to figure out how to paint it. How to describe that pile using the laser shots, and that it takes time to do that well. But a lot of times I'll encourage our clients to use the law of averages. Don't sit there and go up and down on a ridge. Shoot across the middles of those things, and you're not trying to shoot in every little cavity. I've got one client that's got an auger type scenario, and they'll have a cone on top of their pile, and they'll have an inverted cone, a void there, like Cassie talked about, and sometimes you can just invert one and the other in your mind, and it works really, really well. Don't shoot too many pile points. Sometimes the tendency is to try to overshoot, and that's not going to help you. And then use the checkpoints when necessary. And all the lasers have got filters on them. So if you're shooting kind of through something and you want to get to something that's further away, you can choose a far filter. If you're shooting, there's several things kind of in your viewfinder, but you want to shoot the one that's nearest to you, you can choose the near filter. And so, again, there's some filters in there that are easy to access on the laser itself. And make sure you're aware of those and can use those. And then it's okay to start over. If you do this very often, you're going to realize that sometimes you make mistakes, and it's okay to start something over and do it right. So it's great technology, and our goal here today is to hopefully introduce you to it and encourage you to use it.
Thanks so much, Johnny. That was very good, very good. So the MapSmart solution summary, in general, whether you're mapping stockpiles or you're doing asset management projects or laying out landscaping for a new house, you can choose how you measure and what data you get based on what it is that you're trying to achieve. So you can use it with or without GPS. You can use, start a survey with zeros and unknown coordinates. You can use known coordinates. You can use resection with MapSmart and use 2 known positions to determine where you're standing and start measuring that way, which works really well for stockpiles and bins. Depending on what kind of accuracy you need, you can get all the way from millimeter accuracy to 30 centimeters plus or minus, depending on which laser that you choose to work with or that you have from laser technology. You can know your answers right in the field, which means, you're able to make decisions faster. And then also just the BYOD thing, again, if you have a GPS device that's Bluetooth, you can use that. If you already have an Android device, you can use that. And then, of course, MapSmart is just a one-time, license cost. There's no subscriptions or anything like that to make it painful to own. And go ahead, Paul.
Go ahead. Yeah, so this is part of this webcast participation, we are have been promoting a giveaway of really winning a complete mapping system that would include a TruePulse 360, an actual Cedar tablet, and then the license key for MapSmart as well. If you happen to visit us at the ESRI conference just about a month ago, and are on this live webinar, you actually will double your chances. So we do have your information when you logged in or joined us today, just putting in your email. We'll match that up with the emails that we collected at the booth, and we'll just basically put your name in the hat twice, and really wish everyone a good luck on that. So we'll be announcing that winner here probably in the next week or so via email. And then as far as the availability of getting the software, right now you can get it on Google Play. If you search LaserSoft MapSmart, that will pop up. You'll be able to download it, and then you would actually have to contact a authorized dealer in your area to purchase a license key to actually activate it. And you find your dealer actually just by going to our website. If you go to lasertech.com, and then you hit the professional measurement division and then where to buy. This will actually, you punch in where you're from, your zip code, what application you're working in, and that will pull up a dealer database and give you, the contact information of reaching out to a dealer. Of course, you can contact us directly. We can certainly arrange to get a demo set up at your facility. If you call us, and that number is 1-800-280-6113. And then here's some other contact information too, and we certainly do want to open it up for some questions. I did see some questions come through just here at the end, so I'll go ahead and ask those, and then we'll see if anybody has any more. One of the questions came back about what volume accuracy can you get using the TruePulse, and then obviously that's going to be dependent on the equipment, but maybe, Johnny, you could speak from your experience of what you've done.
Yeah, so the goal in any measurement is probably to be within 5% or less. We've done some testing where we've measured the same pile several times to look at repeatability, and those are generally very, very close, and 1 or 2 or 3% as you remeasure piles. But certainly a goal would be, I think most people are shooting to be 5% or less in terms of their accuracy. That's kind of what I've seen across the board.
Right, and that's totally achievable with a TruePulse 360 like you're used to using, like you typically use. And then if you bump up the accuracy to a TrueAngle 200X system, you can get within 3% of actual.
Great. I had another question that come through. If you cannot shoot back to the original start position to perform a closed traverse, they're asking how do you finalize the final project using an open traverse function?
It is going to go in there. You saw on the screen there open or closed, and so if you can't, sometimes you just can't physically shoot back to the original location, and that's fine. It's going to estimate that and give you an accuracy based on an open traverse. I don't know what the actual calculation is. Cassie, you might be able to shed more light on that, or somebody that the programmer might be able to do that. But I know that there are situations where I have had to rely on an open traverse calculation there. It's not going to affect the volume in the lease. It's simply an independent audit of how well did you go from control point to control point to control point.
Right. So you don't have to do a complete closure in order to get your volume calculation.
Yeah. But it is helpful. It gives you good confidence that you've done a solid measurement on that particular project. Right. Great question.
Great. We've got a couple of questions here. When would it be important to enter the declination value in the TruePulse 360?
So particularly if you're moving from east to west, if you've got say you're a company with two different locations, and there's one that's 100 miles either direction, east or west, then I would definitely change my magnetic declination. There's a great app, free app there called Magnetic Declination that you can download, at least on an iPhone. I don't know if it's available on Android or not. Or you can also go to the NOAA, NOAA.gov or something like that, and they've got a magnetic declination calculator. So you can plug in your lat long or your zip code, your area code there, and it's going to give you the magnetic declination for your area. And it changes on an annual basis. So just because it's maybe it's 2.3 this year or minus 2.5 this year, it may be something next year. So you want to kind of check that. I actually just every time I go somewhere to do a demonstration for a client or actually measure, I'll just open up the app and it'll tell me based upon where I am what the declination is, and I'll plug that in. So north and south is not as critical as east and west, if that answers your question.
Great, thanks, Johnny. Just have another question here. Can the laser technology be used to determine a water surface elevation from a bridge? I could probably speak to that. We actually do have sensors. They're not necessarily the same type of technology that you've seen in this presentation with the handheld TruePulse laser, but we do have industrial sensors, and we just did released a unit. It's the TrueSense, and it's the S300 series, and that does have the ability to be aimed. It needs to be mounted. It has a bunch of communication protocols and that sort of thing. But yes, it can help give you at least the level measurement to the water surface. So that we do have that technology, just in a different division. This is our professional measurement division that we're kind of promoting today, but we do have an industrial division as well. So if you are interested in learning more, just please reach out to us, and we'll absolutely address any questions or get you a demo unit on that as well. Does anybody else have any other questions? We're going to go ahead and try to wrap this up. I just want to make sure we do address the questions. We do have a question here. Will you go blind if a laser hits your eye?
No. Our laser technology, 905 nanometers, is eye safe. So you don't want to just go and aim it into someone's face for hours on end. However, you won't inadvertently hurt anyone using our lasers with a crowd of people around.
It's more of a,
at least with a TruePulse. Right.
Laser. Yeah.
Right. With the TruePoint300, our newest laser, though, our little mini total station, it does have a visible laser that is you don't want to shine in anyone's eyes. All the TruePulses, though, are 100% eye safe.
All right, I think that's it. So go ahead and wrap it up. I do want to thank our guest speakers today for taking some time and demoing the MapSmart on Android. So thank you both, Johnny and Cassie. And from here, we'll go ahead and, if you guys want to have any closing remarks, we'll go ahead and wrap it up.
I was just going to mention one thing, Paul, that the system, if you're looking for a very inexpensive, simple way to measure whatever kind of stockpile, again, that's mostly the measurements that I do. Certainly, Cassie covers some other measurements there. But if you're looking for a stockpile measuring solution, it is very effective, very simple to use. It's one of those ones that you can put down for a month at a time and pick back up, and then pick it and just go right into it. Other solutions that we sell for GPS or or other applications, you better be using them all the time or you're going to kind of lose track of what's going on. This is not like that. It's very simple technology. Again, if you've got any questions, feel free to call me. My number's there, and we'd be glad to help you. So.
Yes, and I want to thank everyone who joined us today. Thank you very much for spending your time with us to learn about MapSmart. Appreciate it very much.
All right, thanks everybody. We'll go ahead and conclude the webinar, and we will let you'll know on the winner of the mapping system. So thanks again for joining.